So this is a demonstration of gravitational force. You can see that as I move this figure closer to the other, the force increases, and as I move it further away, the force decreases. This is because the force of gravity is equal to g times the mass of the first object times the mass of the second object divided by the radius squared. The radius is the center of this object to the center of this object. Now you'll notice that as I increase the masses, because the masses are in the numerator, the force is going to increase. But if I make this one smaller, it's going to get smaller. It's important to know that, say, if this is at 48 or 47 and this is at 40, you can see what it is. But if I change the red sphere to 47 and the blue sphere to 14, the force is still the same. This is because gravitational force is shared between the two objects and it acts on each in equal amounts. So after this has been recited, it's also important to note that gravitational force is always present. So if I move the figures beyond where the eye can see, like this, and then I decrease their masses as far as it will go, you'll notice that it says on the simulation that the force is equal to 0 newtons. However, this is never actually the case. It's just that the simulation will no longer make a measurement of force. Which means, if you think about it, when the Earth revolves around the Sun is pulling on the Earth, and the Earth is pulling on the Sun. But it's also true that as you exist in the universe, that you are also pulling on the Sun.